One of the tracing exercises in Chapter 5 deals with decimal to binary number conversion, and so this is the good time to review that, or if you haven't seen it lately, or if you haven't never seen it, this would be the time to learn it. We do test you just very briefly on this because we expect you to be comfortable with between those two number systems. It's not a big part of this class, but here we go. Okay, so, and also, here is how you're going to be able to save birthday candles from now on. Yes, if you are a geek like my family, then if you're, say, 43, which is the age I just turned, that's a lot of birthday candles. In fact, I would have to buy at least two packages, possibly 3 packages of birthday candles, and let's say I just don't want to have that many candles. So here's how you can use way fewer candles. Review of decimals first. I know that this is going to hopefully be reviewed for you guys, but in any base, our base is 10. The places of the numbers go the base and then raised to the power. So here's just a couple here. Now, in elementary school, we call these the ones because 10 to the 0 is 1. The tens because 10 to the 1 is 10. The hundreds because 10 to the 2 is 100. And the thousands, and etc. 10 to the 4. 10 to the 3, when I totally skipped 3. Let's write that one again. Thousands, brain fart. Okay. So if I have a number like, I don't know, 3762. This is 3 thousands plus 7 hundreds plus 6 tens plus 2 ones. That's how we sort of learn it when we're kids. All right, and that's really just saying 3,000 plus 700 plus 60 plus 2 is equal to this big number. Now, if I'm doing this in base 2, it's the same thing. I'll just do it over here. If I have a number in base 2, my base is 2, and I use the same numbers for powers going to the left. So 2 to the 1, 2 to the 2, 2 to the 3, etc. And then my only options here are zeros and ones. So just to say over here, base 10, in each one of these places I have the numbers 0 through 9 that I can use. If over here in base 2, I only have the numbers 0 through 1 to use. So then let's just fill in some zeros and ones. Okay, so I have 1, 1, 1, 0. Now what does that mean? That means that I have 1, 2 to the 3, which is 8, 1, 2 to the 2, which is 4, 1, 2 to the 1, and no 2 to the zeros. This is still the ones place, by the way. 2 to the 0 is also 1. So if I were to write what these numbers actually are, they're 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 4 is 8, 2 to the 2 is 4, 2 to the 3 is 8. So I have 8 plus 4 plus 2. So 12 plus 1 is 13. This is the number 13 in binary. So let's do a couple of conversions. For one, here's my birthday candle. Let's see how many candles I would need in order to put a candle on my cake. Actually, my friend threw me an ice cream party, so I didn't have a cake this year. But if I had had a cake, let's find out. So this over here was converting a binary number and how I would figure out whether it's how to get it to decimal. Just take the ones and add them up, 8 plus 4 plus 2. If I have a decimal number and I want to convert it to binary, I have to understand what the powers of 2 are. So here's my blank slate for converting number 43. 43 base 10, sometimes you put a little 10, just to say I mean base 10. So I know I have the ones place the 2, and then I just keep multiplying by 2 as I go over here. As you go, if you haven't seen binary numbers before, you probably will start being like, oh, that's why my RAM is like 64 or something. Like, that's why those numbers. Why didn't they just have 100 gigs? Well, turns out everything's a power of 2 in computer science. Okay, so this is a nice, easy way to do it. I just write out the possibilities here, and then I can say 43. Well, the biggest thing that goes into 43 is a 32, so I know I'm going to have a 1 in that slot. And then over here, I can kind of keep track of how many I have left. Often I do this in my head, but let's do it out. 3 minus 2 is 1. Okay. So in this case, I have 11 left over. Well, a 16 doesn't go into 11. Can't fit into an 11. An 8 can, so I can get 1 8 in there. Let's get rid of the 8 now. 4, nope. All I have left is 3. But a 3 is 2 plus 1, so I got a 2 in there and also a 1. So this is what my number 43 is in base 2. That's how I convert decimal to binary. Maybe one more binary to decimal conversion, and then we'll be done. Oh, so by the way, birthday candles. So what you do when you're putting this on a birthday cake is you put out 1, 2, 3, 4, you put out 6 candles, and then you only light the ones. See, huge savings. Okay, you heard it here in CSI 110. Let's do one more of the binary conversion. So 1011010 base 2 equals what? Well, usually what I do when I'm converting here, just to make life easier for myself, is I write the places under it, and then I can just add them up, and I can make sure that I don't make any careless errors. Especially if you're doing this on an exam. Like, you definitely don't want to make any errors that when you're nervous. So 64, I got a 64, a 16, an 8, and a 2. And then I just add those up together. 10, 10, 2 plus 6 is 8, and 9. 90 base 10. I hope this helps with the tracing exercise in this chapter.